I want to talk about function in C. Function in C is very similar to other languages, but before we move on, I want to tell you guys some major differences. The first one is all the parameters have to be defined. What I mean by that is the data type has to be defined towards the very beginning. Secondly, we need to mention what data type we are returning. Lastly, function in C, you can only return one single value. So on the screen is a C code that's written in a Python-like style, since you guys taken Python. Well, in Python, we're able to define the function anywhere, and then we can put the caller anywhere that you like. But in C, that doesn't work. Therefore, in C, to write a working function, what you need to do is you either need to declare the function towards the very beginning of the code, and then you write the caller function in the main function, and then you define the function below the main. Or you could do it this way. What you can do is you can define the function before the caller, and then you can call the function wherever you like, but it has to be below the definition. This time, I want to show you a working C code. I defined the helper function above the main, and I called the helper function within the main. The helper function is multiplied in two numbers, and it takes in two parameters, and they're both float data types. And let's dissect this even more. To start off, you first have to write the data type that you want to return. So in my case, I wrote float. And if we look at the return statement, I have x and y. I set both x and y to be float data type. If we multiply those two things, we get a float data type. So it is a good practice to match the data type of the returning statement and the expected statement. I mentioned that the parameter data types have to be mentioned. So I wrote that both x and y are float data types. So I wrote float. So lastly, remember that we can only return one single value. Before we go further, I want to talk about the major difference between pass by value and pass by reference. Today we're going to talk about pass by value. In the upcoming lectures, I'll teach you about pass by reference. On this screen, I have a C code with a helper function called exchange. The exchange holds two parameters, and they're both integer types, and they're called A and B. What the exchange does, it simply just exchanges what variables A and B are pointing to. So A will eventually point to B, and B will eventually point to what A was pointing to. If we look at the main function, I have x to be 5 and y to be 10. And I called the exchange on those two variables. So we should expect the output to be x equals 10 and y equal to 5 after we called the exchange. But something weird happened. If we look at the output, the exchange never happened. X is still 5 and y is still 10. And the reason why this is happening is because we are only passing by value, and we're not passing by reference. So in the upcoming lectures, I'll teach you how we can pass by reference. Here's a real-world example of pass by value. Suppose my grandmother has a recipe book, and I visited her place. I like one of her recipes, so I decide to jot it down and make a copy of it. And then I take it back home. Now I could do whatever I want with a copied recipe. I could simply just follow the recipe, or I could make some changes to it by adding MSG because I'm not a good cook compared to her. So this is what pass by value is. We simply just make a copy of the original, and we make whatever changes we want. And whatever changes we make do not affect the original recipe book. And that's what pass by value is. If I really want to change the original recipe book, then I need the exact address or the location of where that original book is located. So once I have her book, once I have her address, I can go there, I can make whatever changes I want, and then in the future, whatever copies that we make, will be affected because I made that change to the recipe book. And that is what pass by reference is. So we get to have the address, and since we have the address, we can make whatever changes we want to it. Now, let's look at some examples of how the computer handles this. So I copied one of the functions called multiply two numbers, and the parameters are x and y. And we mentioned that it simply just multiplied those two variables. So if you look at the main, I have float a to be 4 and float b to be 1. And then when I called the multiply two numbers, I wrote multiply two numbers a comma b. So this is how computer is doing pass by value. The computer is not taking a and b. It's simply just taking a copy of a and copy of b. So let me stress this one more time. What we are seeing right now is pass by value, where we're just copying what a and b are pointed to. So whatever changes that we make have no impact on the original, which are a and b. If I really want to change a and b, then we need the address of where a and b are located. Once we have that, we can change whatever a and b are pointed to. Now that you guys know how to make functions, I want to teach you guys a new tool that you can use to improve your programming, and it is called the exit function. The exit function is part of the standard library, so you have to include it in the very beginning. And what it does, it is simply just terminates the program. The exit function will return an integer. So usually 0 means the program went well, and anything besides 0 means the program did not go well. Let me show you a quick and easy example. So I've written two programs right here, and then one of them is called return x.c, and the other one is called exit x.c. So these two programs are exactly the same, where they ask for our input, and based on our input, it prints out whether if it's a non-positive or if it's positive. So the only difference here is line number 12. On the left side, I'm returning 1, and the right side, we are exiting with 1. So now below is the terminal for both programs. So I've already typed the GCC, and I already ran the program, and now I'm about to run the output file. So as you can see, it is now asking for our input, and I typed -2 in there. So let's keep on running this. So now if we compare these two outputs, they're exactly the same. They printed out that both of them are non-positive integer. So I want to teach you guys about the integer value that I mentioned. So if you look at return and exit, they both have 1, right? So let's try to print out that 1 there. So what we do is we call echo space $? If we run this, it tells us the integer value that has been returned. So if we run this, we both got 1. Because if we look at line 12, when it reached there, it simply just returned 1 back to the OS, back to the owner. If we look at the right side, it exited with 1, so it immediately terminated it, so it returned 1 back to the owner. So let's look at this carefully. Does this mean that exit and return are exactly the same? Not at all. They're actually completely different, actually. So let me repeat what I said earlier. Exit terminates the entire program, while return ends the execution of the function and returns back to the caller. So the reason why we both got same results is because for the return, it simply returned to the owner. there was no caller to the main. So now let's look at an example where exit and return are completely different. So on the screen, I have these two programs right here. They're exactly the same. Okay, so they print, and then also the helper function also prints extra things. The only difference is line number 6. So on the left side, I'm returning 2. On the right side, I'm exiting with the value of 2. And on the bottom, okay, I also wrote the terminal. I've already ran GCC for you guys, and we're about to run the output file. So let's dive in. So once I called it, okay, once we ran it, the outputs are really different. Okay, so on the left side, okay, it's called, we are about to call helper from the main function, and then it called the helper function, and the helper function, it printed out helper is called. Then it returned, so then it returned back to the main, and then it executed the rest of the code, which is we came back to main. On the right side, we have a complete different result. So if we look at this, okay, we start from main, it printed out line number 11, so we're about to call the helper, it goes into the helper, and then it printed out line number 5 where helper is called, then it meets the exit. So because it is exit, it immediately just terminates the program and it doesn't go back to the main function and execute the rest of the code. Now, let's try calling the echo. So if we call echo $, on the left side, we have 0. On the right side, we have 2. The reason why it returned 0 is because after the helper function returned 2, it went back to the main, and then it executed the rest of the code. Once it met return 0, not only it completed the code, but it also returned 0 back to the owner. And that's why we have a 0 there. Let's look at the right side. So once we called the echo, it gave us 2. Now let's look at the code here. So in the helper function, once it printed out the helper is called, it then met with the exit with the value of 2. So it terminated right there, and then 2 was returned to the owner. So this is where we see the difference between the exit and the return. So why do I want to discuss about this? I mean, what's the point? What's the usage of the exit then? Well, we use exit mainly for debugging purposes. So suppose you have like 50 functions, okay, and you have no exit. Then what will happen is when you run the code, it will run all 50 of them. So that it doesn't give you the opportunity to check if the helper function was working correctly or not. So if we put exit in there, it makes that pause. It immediately terminates it, and we can check if the code ran correctly or not. So let me just remind you once again. If 0 is returned, that means the program went successfully. If some other weird value was returned, then that means something went wrong with the program. So you can use this to improve your programming and also helps you to check your helper functions. Let's talk about a technique that you learned in your previous course. It is about recursive function. So recursive function is a function that calls itself until it reaches a base case. When the base case is reached, the answer is then returned to the previous caller until it reaches the first called function. So let's look at a really small example. So this example is about factorials. I made a function called factorial, and the base cases are when it reaches 0 or 1. Otherwise, we will return that number times the factorial of the number minus 1. So if we choose 4, then Factorial 4 will return 4 times factorial 3. Factorial 3 will return 3 times factorial 2. Factorial 2 will return 2 times factorial 1. And factorial 1, well, that's the base case, so we just return 1. And that 1 is returned until it reaches factorial 4. So the final product should be 24. This is a really small example, but I'm sure that throughout your semester you'll meet another problem that deals with recursive functions. So it's better for you guys to get familiar with this right now.